2. Part 2, you quickly reach the farthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. For example, the above loop encloses merely 4 tiles. The 2 pairs of dots in the southwest and southeast marked I below. Middle tile. Okay, so these 2 here. Interestingly enough, okay, there's a path. In fact, there doesn't even need to be a full tile path to the outside for the tile to count as outside the loop. Okay, that stinks. In both of the above examples, 4 tiles are enclosed by the loop. Here's a larger example. The above sketches how many random bits of ground, some of which are in the loop, some of which are outside of it. Okay. In this large example, 8 tiles are enclosed by the loop. Any tile that isn't part of the main loop. Here are just the tiles. We have the same input. Okay, this is example 10. So we get a couple different examples here. This is the interesting edge case that is going to be hard to solve. So I think more or less, if we want to count if something is contained within something, I think the answer is if the number of lines it crosses in a given direction is odd, then it should be contained. So in this instance, if we look at this one here, if we go right, there's only 1. If we go left from there, you can see there's 1, 2, 3, which is odd, which means it should be contained within. I think we only really have to go one direction maybe to really figure this out. But then it gets weird here. So if we look at this 0, you know that if we go left, 1, 2, that's even. If we go up, 1, 2, it's also even. If we go down, 1, 2, that's also even. So we know that this 0 is not contained within. And I think this edge case of even if the 2 pipes are right next to each other makes sense because it's actually easier to calculate like this 0 with this rule of how many times does it cross the line kind of thing. But what makes it difficult is this scenario here with the 7 pipe in J. So I think the way we're going to have to handle this is that, and this can happen multiple ways, but when we cross 7 going down, if an L is here, then we know we've crossed the line and we're not riding the line. So we just got to figure that out. So I kind of want this example because I feel like this is what we want for our test. So part 2 is going to include part 1, which is kind of nice. I like when that happens. So let's get part 1. Could probably functionalize this a little bit better, but we're not going to because I don't care. So part 2, we're going to get our winner. And then I think what would probably be easiest is that if we so this is all of our points. And so can I do no, I can't. Okay, we'll just go this string. It'll be all right. Wait, just making sure. Okay. You can use structs for keys for maps, but I didn't think a slice would work. We'll go the string, and then what we're going to do is we're just going to populate it. The reason is I want a quick way to look up for any given dot if along the path it runs into one that's in the loop. So we're just going to pre-populate this lmap sub Okay, so it's going to populate it. And then, so easy solve, hard solve. Let's talk about the easy solve. So we want to count the number of points that are contained within. That's our problem. In this case, figure out whether you have time to search for the nest, calculating the area within the loop. How many tiles are enclosed by the loop? Okay, so what we can do is say for S rows range of matrix, and then for so we want to check each of these points, and so first, if we find the point in the map, we know it doesn't matter. Do we only want to... Okay, so it's not just ground. Okay. So that was my next question. Could we eliminate anything that's not ground, but doesn't look like it? Okay, so... Okay. So the next thing we want to do is... if x equals 0 or y equals 0, that automatically, because then it's on the edge, so that's any of these on the left and these in the middle, like on the top here, those don't count. I don't think. If they were in order for them to be encapsulated, they can't be on the edge. And then we can say or length or x equal to length of the matrix minus 1, or y equal the length of the matrix minus 1. So if it's on any of the border, we don't count it because it's not going to be encapsulated. So let's do... And what else we got? We've got... All right. So we got the matrix and the loop map, and then what we want... We're going to check for an X or Y. So I suppose, how big is our input? It's not crazy. Okay. Actually, I think I have a different idea. If we, for a more optimal solution, if we come from left to right and we count the number of times we cross the line on each one, we can mark each bit in the slice or in the array, each XY position, as whether or not it's contained within the loop. So rather than doing this and checking each one, which is where I was headed, we're going to create a separate map. Call it contained. Yeah, actually, this is essentially what I want to do right here anyway. We really only care about this relationship of on the pipe for values that are in the loop or on the loop. Everything else are just like extra characters, kind of add confusion. So what I'm going to do is I'm going to iterate through, and if low dots contains, we're going to look for inside the matrix we're looking in our loop to see if this XY exists. We're going to continue. It's okay. We have a map right here. We could use it. This just becomes X and Y. What I'm doing here is I'm saying if there's anything that is contained within, we're going to, or is part of our loop, we're going to skip it. So if we're on the loop, we don't want to manipulate anything. But if we're not on the loop, then we want to replace it because we want to get rid of garbage. So then what we can do is M sub X sub Y equal to period. So now that we've got our loop, we replace everything that is garbage characters that might add some confusion. And we get rid of those. And so what we're left with in our grid is something slightly less complex. I think what I need to do here is, so we're going to simplify this a little bit. Because I replaced all the characters that don't matter, the only characters that are really left are dots. We actually don't have to do this check each time. As far as like, is it in the map or not? That gets removed and reduced. Okay. And then as we're riding along this, we need some sort of direction. So we'll refer to this as maybe up and down. And we'll assign it a false value. Anything on the edges, that's fine. We're going to switch this up a little bit and think instead about the things where it contains, or rather where it is in pipe, we'll think about the times it's not in pipe. And what can make it in loop, right? So if our string contains this, then up is false, and within so anytime we cross a pipe, that means we're gonna flip states for the loop, and our up is going to become false. So there's really no up down to track there. So if equals F okay, so let's look at these different scenarios. So we're going to loop through. We're going to ignore the outside. Fine. If we've got a pipe, we're going to say that we're in loop. If we cross an F or an L, we don't know if we're in loop yet, but we know that we're up is going to be equal to our character equal to L. Let's do this to simplify. And then similarly here, if we've got the 7 and the j, then we want to check to see if up and c equals j, within equals not in loop. So we inverse, and then we invert this as well. So if we're 7, and actually we can, no, we don't want else here. So yeah. So then we can get rid of our other approach. There's nothing really for us to do with the character. And then instead of doing this, we can call in loop. And then we add it to our contain set. All right. So what do we got to do here? If it's a pipe, we're always going to flip. If we get an F and an L condition, up is going to be that character, whether or not it matches L. I think this is where I'm messed up here. So yeah, let's loop is false. So I shouldn't need this at all. Ah, here we go. We only want things that are not in loop. I think I need to subtract the length of our actual loop itself. Let's look at test 3 for a second. Okay. Test 5. Definitely replacing characters that are not in the loop. I think one doesn't really fit for case 3, but let's remove that. 31. All right, let's look at case 3 for a second. So it's 1, 0, or we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1 times 9 is 99 minus 31. 68. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Anytime we pass one of these, we inverse it up. Okay, this doesn't make any sense. I do think, hold on, minus length of mmap, or lmap. I think this is my problem. Because after I cross this, I need to set up equal to false. And then I really just want the stuff that's in the loop. I don't care about this other stuff here. So I still think there's an issue here where I need to subtract everything in my loop. All right, let's reduce this down. Let's make some traction here. I'm spinning wheels and not doing anything productive. So let's look at our initial test 3 case. What are we looking for to be in here? Well, this is 2, 1. So 0, 1, 2, 0, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 3, 1. Okay, so I need to know state, but lmap. But I don't want it to be contained in my loop. Okay. More complex case. Okay. 10's actuals 14. So you got 4 positions that aren't right here. Does it give us in the AOC stuff which exact positions? Oh, sorry. I have this screen up down here. it doesn't, but 0, 1, 2, 3, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 3 and 14, okay, that one's good. 4 and 10. 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, and 13. 4, 10, 11, 12, and 13. 4 and 18. That's 13, so this would be 14, 15, 16, 17, 18. So 1, 2, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, what else we got? It's 1 of 5 and 11. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, 5, 11, 12, and 13. And 12 and 13. 5, 17, 19. Something still is not driving here. Let me print my LMAP for a second as well. So I think, am I not replacing? Hmm. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Why is it only going to? Oh, I'm. Man, here's the issue, guys. Okay, so what I'm trying to do is sanitize the matrix and get rid of all the extra characters, and I was not ranging on each row. So what was happening is it was just giving me the same values for X and Y. So we were only doing a partial grid. This should work now. So let's bring over tests back. All right. So all our tests pass. So let's look at part 2 as an actual value. $296. That's not the right answer. All of our test cases pass, and yet I did not get the right answer. Part 2. Let me read the text. In this example, tender questions whether you have time to search how many tiles are enclosed by the loop. Same puzzle input. What am I missing? So I'm only doing horizontal scanning. There could be, in my puzzle input, a vertical scan issue where, but I think horizontal scanning should cover all cases. So it's a little bit hard to see here because of the width or the font. I'm going to zoom in, but you probably won't be able to tell. But if we look at S, we've got a dot above us, pipe to the right of us, an L here, an S here, and an L here. So we need to figure out of these four which character it is. So we know we're getting a west connection to a south connection. So a west to a south. So a west to a south is a 7. So how do we determine that? Let's just so what we can do is determine 7, or we'll just say replace 7. S, replace S, and we're going to take in the matrix, which is slice a string, and we're going to return the matrix. And so first we're going to for X and M row range M, and then we're going to for Y V range of row if V equal to S. So now we know we found S, right? And we got to check a couple things. We're going to check the 4 characters around it. We know that if it's coming from above, so in order for S to be a pipe, right, there's 4 characters it could be, right? Let's go back to this. Yeah, we don't really need to check the other characters. We just need to check a couple of conditions. So if V equals S, in order for it to be a vertical pipe, we need both the above and below to be in the matrix. So we're going to also pull in the L map, which is a map of string to bool. Really kind of regret that choice now, but we'll just keep running with it because, yeah. It's not contained, it's L map, but it's the same concept. So, and since we're on X and Y, in order for it to be a vertical pipe, we need to check to see if we have a value above. So that's going to be -1. And if that's true, we need to make sure that that value has to connect on the south side because it's above. So it has to be that, and V strings dot contains has to be a 7 or an F. And we'll go with, except it's not going to be this, it's going to be M sub X minus 1 Y. So if the above connects from the south side, and it could also be a pipe, So if that's true, and also the one below it, which is a +1, so it's allowed to connect, so it can be LJ or pipe those. So not only is the above existing in the map, but also the below is existing in the map. Then we are going to set M sub X sub Y equal to the pipe. And then we're going to return M. Okay. So that's one condition. Now, let's go from above to the right. So still the same connectors from the top. This works for above and below for a straight pipe. So if we've got one of these coming in from the top, so 7FJ, no matter if it's east and west, doesn't matter. What matters is whether or not we can go left or right. We're only going to have one connection in, so I don't need to check both. No, I do need to check both. I'm going to have two connections. Yeah, so if it comes in from the north and we're not going straight down, right, then it can either be I feel like there's a better way to do this. That means it connects north to east, which would be, these would need to be a west. So these are allowed to be J and 7. So that's because it's going to hook. If our incoming comes in from the north, then we got to check to see, is our connection to the right capable? And if that's true, then this is an L. Similarly, if we want to check left, this is an L or an F. L connects north and east. So this should be east and west, but because we're going east, it should be J and 7, which is anything west, because it can go up or down. Right. Okay, this is fine. So we can go up or down from there. And then similarly, we check to see if the one on the left side or on the west side, and that means that it is connecting on the east side, which would be F and L. Either direction, up or down, doesn't matter. And if it is, then we know we are going from north to west, which is a J. All right, so it's 1, 2, 3, 4, 5, 6 of our conditions. We've got 3 listed here. So this one is kind of straightforward. If our x minus 1 and our y plus 1, so that's to our east and our west. So if our y minus 1, so that's our west side, is if our west side, did I mess this up above? Because we went x before, which was up. But that's south side. That's fine. Okay, it's fine because they're connecting to the south side of things from either east or west. Okay, it's not going to be the same then. It's going to be east. It's going to be anything that is connecting to the east. So this would be L, F, and this. Yes. Then this should be on the west side, should be J7 in pipe. 7 in pipe. Okay. So if that's true, then that is that. 2 more conditions left. We have, was it F and 7? So let's look at F. So F is a 90-degree bend connecting south and east. So that means our north and our east. And finally, our 7 should be, our 7 connects south and west. What's our F connect? Our F connects south and east. So we need to check that, but this changes to -1. And then only the things that connect from the left are allowed, I think. This stays the same. -1, I think. 2, 3, 4, 5, 6. I think that will do it. So what should our S be? If we look back at this, our S should be getting from the west and providing to the south. So west and south. So it should be a 7. So let's set a breakpoint here, and then we're going to run that. Okay, so let's look at a couple of our inputs. Let's just see, in this case, it should be an F. All right, so in order for this to be a 7, 7 connects what? 7 connects the west. So the west, and it connects the south. Connects the west and the south. Okay, so let's look back at this here. So the west needs to be an L, and the south needs to be an L as well. Why an L? North, north. So an L, a J, or that. All right, let's give that a shot. There we go. All right, that took way longer than it should have, but I've nailed day 10. There's actually a few more issues here. So I was specifically targeting what I knew the character should be. These mappings need some more review. I could have went into the text file and just altered them, but I'm not going to do that. And for this video, I'm just going to not worry about it. So this is a bit of a struggle bus for me, but let's kind of review the solution in whole, and then we'll talk about implementation. So the first part of the problem was to create a loop. And so the way we did that was we looped through every single, I decided that we were going to do a recursive function called move. And so that move would take our starting position and then our destination position. And we start by seeding that with wherever S is, plus, minus, plus, and minus in the XY positions. That goes to the top, bottom, left, and right index. And then from there, each of these would just append to a slice, and then we would loop through each of our slices, and we would see, does it finish on the S? So only if it finishes on the S is it considered a full loop. That's pretty straightforward in itself, but we wanted to make sure that was true. And then whichever one has the greatest length. This isn't really true for the puzzle input, but assuming that multiple things could loop into S, I think it's conceivably possible where you'd have an inner loop and an outer loop. So just to make sure that that wasn't a problem, we went ahead and did that. So let's look at what move actually does. So it takes in our slice of winners, and it appends to it. And the way that it does that is, first it just says, hey, are we outside the edge? It's not going to be considered part of the loop. Then we just grab a distance calculator and we grab the character. If we are period, we don't care. We move away because that period is not a pipe. And secondly, we want to check if it's S. If we've gotten to S, we've kind of won. So we're going to return that, and it's going to append all the way up recursively through move, as you see here. So if it's one of these characters, we make a decision on which direction to head. And then we recursively append to this slice each move in the stack. So what you end up with is a stack of XY positions of the entire loop. So each of these blocks are just to determine what direction we need to head or what directions are valid. And then we don't necessarily know what direction it's going to head from here, but we know what directions are valid based on what character we have. And so we call the appropriate move function and append to that. So that was pretty straightforward. No big deal there. We had a couple of helper functions like get start. Part 2 is where it gets like really dicey and required a little bit more debugging for me. So we do the same thing. We get our winner. Yes, we could have functionalized that. I did not do that. Then what we do is one key takeaway here is that S is something, a pipe, and we have to determine what that pipe is, and that's going to be based on the 2 connections it has to it. Based on what we've seen from the input, it's only ever going to have 2, and I think it actually states that in the puzzle results. The fast way to do this would be just figure it out manually and replace it, but I did it kind of programmatically here, although it needs some more test cases. I think one thing to note here is I probably, based on the speed in which I did this one, I really should use more test cases for intermediate, smaller functions or functionalized tests. Probably help me go a little bit faster in the future. So then I create this contained map. So this is just a map of every XY position that's contained within the loop. And then I landed on this solution finally, which is to indicate, since the idea here is that we're only going to scan from left to right. We're not going to worry about top down. We're not going to start at each position and scan outward. We're just going to do one scan on the entire slice, starting at row 1, and determine if everything in row 1 is either contained or not contained. The way we can do this, really from a calculation standpoint, is if you have some object here, and let's just say it's a full shape, like such, and you have some objects in it and some out of it. When you're scanning from, in the simplest terms, when you're scanning this way, you can count the number of lines it intersects with. So for instance, we have 0 intersections with the polygon itself. So this one's outside. And then we can see we cross into the polygon here. So this one gets a 1, or a count of 1. So we know we're inside, out, inside. And then because we come out again, this becomes an out as well. Now, you can use a Boolean operator, which is what we did there, by just going yes or no. But then this problem became a little bit more complicated because you would have a scenario where this was valid. And this is really where things started to get hung up. Instead of using the simple count, so let's imagine if we change our polygon to look like this, just kind of basically the example they showed already. Like this, even though this one here counts as outside. And so what we had to do is we had to calculate what the up position is of each corner. And then based on that, we could ride it along. So that's really where a lot of the complexity came from. And so this is what this kind of handles. That's why we have this up and in loop. And then based on whether or not it's in the loop and whether or not it's in our L map, which is our loop map, we determine whether or not we're going to post it on the screen. So I can get rid of this. That's pretty much that. So this was a long one, way longer than I anticipated. I'll shave it down somewhat, but we'll get it out as soon as we can. All right, as always, over and out.